Hello. Is it fine, right, voice? Hey, where are others? Went home. You decided to enjoy when machine learning starts. Wow. Hey, Suri. Yesterday you are not there? Health is not good or what? Very good morning, ma. Good morning. Sharing my screen. We are doing a new story we are asked to create based on the free bus. So, hey mom, hello kid. Mom, I got to know that government has implemented free bus service. And yes, I do hear that. Let's go to grandmother house. Okay, sure. And distance, conductor will ask enter a distance. Conductor will ask show me your identity card. And her mom said no. If answer is no, you need to take the ticket. How much the fare? You mentioned your distance 50 kilometers. Enter the fare and total charge. If your answer is yes, enjoy the free trip. I need to add one more condition out of state girls also. That is, but this kind of questions for Jubi for you right now. You can easily do that. All these things. That is very good. So let's start about the thing that is. So don't okay. Don't skip the classes because machine learning started and you are not coming to class. Ah, not a linear regression, right? Where is your file? I will give the assignment. I want to finish this EDA. Then I will provide that. Yeah. So linear regression equation. What is the linear regression equation? Tell me what is the linear regression equation now? Y equal to beta 1 into x1 plus beta 2 into x2 plus beta 3 into x3. Very good. Suppose we have three input variables, and the three input variables are x1 and x2 and x3. And then we can write the linear regression equation equal to y is equal to beta 1 into x1 plus beta 2 into x2 plus beta 3 into x3. And plus a beta naught will be there. And this exactly beta naught is nothing but we call this called in the mathematics we call intercept, but in machine learning we call this called bias. What we call this called bias term. And beta 1, beta 2, beta 3 are the coefficients. And x1, x2, x3 are the input variables, and y is nothing but a output variable. So this is the story. Input variable and output variable. And here these things you need to remember this. Yesterday we discussed this, right? At any cost, it's very easy because our life is only dealing with this, right? Now let's go to here. In normal maths, we can write the equation y equal to m1 into x1 plus m2 into x2 plus c, right? generally. So what is x1 to x2 here? A variables. Y also we can consider as a variable only. M1, M2 is what? Slopes. C is equal to what? Intercept. Clear? Then when you come to the machine learning, we are slightly change M1 with what? Beta 1. M2 is what? Beta 2. And C is what? Beta naught. Beta naught. We can't write beta bar, right? That's why we are writing beta naught, beta 1, beta 2 like this. B1, B2, B3. Okay. But actually the equation look like this. Beta naught, beta 1, beta 2. In some textbooks, theta naught, theta 1, theta 2. In some textbooks. So this is your actual equation. This is your actual equation. And in that x1, x2 is what? Input variables. And y is what? Output variable. Beta 1, beta 2 is generally called coefficients. And beta naught equal to what? Bias. Clear? Easy? So here is intercept, it is bias because the concept will remain same, only that language is different. So Hindi mein papa, English mein daddy, Telugu nana, everyone is same, right? Same story. Here also in mathematics, whatever we are understood, in machine learning also same. In deep learning, it will come as what? W0, W1, W2, and this we call what? Weights. What we call weights. So weights in deep learning, in machine learning, bolo, machine learning, coefficients, and in mathematics, slopes. So generally, so slopes, coefficients, and weights. All are very, very same and important. What is the importance of slope? What is the importance of slope? What is the importance of coefficient? Tell me. What is the importance? Tell me, what is the importance? Coefficients is responsible rotation of line. Say it. Say it. Coefficients are important to responsible for rotation of line. And bias is responsible for bias or intercept. Bias is responsible for lift the line. Bias is responsible for lift the line. Coefficients are responsible for rotation of the line and bias is responsible for lift the line. Clear? This is very, very important. Very, very important. Now, I'm just writing my equation. This is a generalized equation. This is a generalized equation. Suppose you have only one variable. You have only one variable. So x1 is only one variable you have. Suppose we have only one variable. Suppose we have only one variable, and your equation will be x1. What happened? Off the light at band karo. Suppose have a multiple variables. You have only one variable and have a multiple variables. So multiple variables. Multiple variables means what? x1 comma x2 comma x3 and so on xn. Now how the equation will be right? We can write xn. Now this is for the, you have only one variable, that is called beta naught plus beta 1 into x, correct? Now can you write the multiple variable equation now? Write the multiple equation now, everyone. beta 1 x1 plus beta 2 x2 plus beta 3 x3 and so on beta n into xn, correct? So this is beta 2. Two variables we have. So x2. Three variables we have. x3. And n variables means beta n xn. And this is called simple linear regression equation. Simple linear regression equation. And this is called multiple linear regression equation. Multiple. Multiple means multiple variables. Simple means one variable. Multiple linear regression equation. Multiple linear regression equation. Simple means only one variable. Multiple means more than one variable. Simple and multiple. And in your question, now Deepak chooses three mediums, right? So Deepak chooses three mediums. What are those three mediums? Tell me. TV, newspaper, social media. He wants to identify his sales. Now, sales is nothing but which variable? Output variable. TV, newspaper, social media is the input variable. Can you make the equation with this now? How the equation will be now? Tell me. Sales equal to TV. TV is multiplied with beta 1. So beta 1. So beta 1, same equation. I'm writing this. So beta 1 into this is TV. So this is the generalized equation, and whenever the variables will come, your keep on your data set changes and the formula will be changes. Newspaper into social media. So this is important. And because we are not providing the equal weightage, equal coefficient, we know that all are not equally important, correct? Because which is important, TV, newspaper, social media, which one is important? Social media. So elegant, so beautiful, looking like a wow. Social media is, we don't know who is when will be famous. That is the power of social media. So social media is very, very famous. Yeah. So this is the equation now. Now this is a, we are saying the linear equation. Why it is linear equation we are calling? Why it is a linear term? So linear and non-linear. Linear, non-linear. Generally, For non-linear, the power equal to more than one, that is called n, whenever n is equal to 2, and the line we called is called parabola. Or circle. And what is the power? Equation. If power is equal to more than 1 is there, that is a very, very common sense point. Okay. If power equal to 1, you need to immediately linear. It is the line equation. Can you please confirm the chart? Everyone is the linear regression equation, and this is the original equation. This is the original equation. In that, you need to explain each and every part. What is each else? Nothing but, and what is bias? How to find? That is the next step. And next one, beta 1, beta 2, beta 3 is what? Coefficients. Coefficients are nothing but in Navy language it is called slopes. It is slope, and it is responsible for the line rotation. So whenever your slope will change, line will be rotated. So why we are so much worried about the line rotation? Why we are line equation as well as coefficients, and we know that. So why we are interesting about that? Let's do that some analysis. So this is the x-axis, and this is the y-axis, and we have some data points is there. Suppose this data point. Suppose this is the one data point. This is the one data point, and this is the one data point. This is the one data point. These are the data points. What is this called? Data draw in the graph, right? Suppose this is a one value is there. This is the one value there. 1, comma 1. This is 2, comma 1. Like that, have some data points is there. Imagine we have a data points is there. Data points is there. Not butterflies. Okay. The data points. So it is look like this. It is generally look like this. As 2 pointers are there like this. 2 pointers are there. So x is there and y is there. Suppose x is equal to 1 value are providing, y is equal to 2 is coming. Suppose 2 is providing, you are getting 4 is coming. Some like that is the data values are there. The data values are there, and you draw here. What you have done? You drawn here. That is, so this is x, this is y. Everyone understood? Now I will draw 3 lines. One line I'm drawing like this, and one line I'm drawing like this, and one line I'm drawing like this. Okay, 3 lines I'm drawing here. Now in this, out of these 3 lines, which line is the best line? What is the best line means? Which line is predicting the values exactly? When I giving 1, it is predicting exactly near about 2. When I giving 2, it is exactly predicting at near about 4. Near about 4. And same like which line is providing? Suppose here I am providing 1. Here I am providing what? 1. I am going like this, like this, like this, like this, like this. Here what I am getting? Definitely, it is some like 5. So this line, when I providing 1 as an input, this line is giving what? 5. Okay. Similarly, when this line, what this line is giving now? Approximately almost 0. When I providing 1, this line is providing what? 0. But when I providing 1, this line is giving almost a value 2. Almost a value 2. Are you getting what I'm saying? I'm repeating again. Understood this? Yeah. Now these lines is nothing but also combination of points. This lines is combination of points. This is original data. Y is equal to is what? Original data. Now you created some ML model. You created some ML model, and again you will pass 1, and you will get some value, right? You will get some value, suppose 3, and you will compare. I have 2 values there, but my model is what? 3 value. That I will compare. Suppose think like that. One more ML model is giving 5. Okay. One more ML model is giving what? 0. 0 or -1. So which is the best one? Which is the best one? First one or second one, third one? Like that, whenever you pass 2 also, you will get one more values. One more values. And the same time, now 1, 3, 1, 2 is the original data. But 1, 3, when you provided 1, it is giving instead of 2, it is providing 3. It is providing what? 3. Again, you can draw some points. You will get some line. Now, in this line, which is the best line? This or this or this? Which is the best line? Obviously, second line is the best line. So that's why now how you are getting these lines? Who is responsible for rotation of the line? Coefficients. So you are changing the coefficients, your line is changing. You're changing the coefficients, your line is changing. So in linear regression, our main goal is to identify the best line. To identify the best line. What is my best line means? To identify the predictions are good. Best line means what? Predictions are good, right? Yes or no? It is passing about original data only. This is not at all predicting. And this is not at all predicting. These predictions are very, very bad. Not even one prediction also good. Not even one prediction also is correct. But here so many predictions are is good. Around to that line. It is neither be exactly equal, but around that line. Around that line. So what I'm saying is, in linear regression, our main goal is understand, identify the best line. Identify the best. What is meant by best line? Means predictions are good. Predictions are good. So generally what happen? Generally, how it will happen? Like see here. Suppose we have a data. We have a data with 100 observations. How many observations? 100 observations. 100 observation data will be there. 100 observation means it is kind like this. Newspaper, TV, social media, sales. Okay. Newspaper, TV, social media, and your sales. This is your original data. This is your original data. Suppose this is the first data point. This is the first data point. Suppose 200 you spent, 200 you spent, and you spent 300, you spent 400, your sales are 2000. And similarly, you spend 150, you spend 250, 250, and you spend 500, 500 rupees. What you are spending in the rupees. So spending on money on the rupees. And here also spending money on the TV in rupees. Spending money on the social media in rupees. What does that mean is called, I am spending 200 rupees for advertisement in newspaper. I am spending in TV 300 rupees. I am spending in social media how many rupees? 400 rupees. My sales are increased how much? 2000 sales I got. Similarly, here also I got maybe 1500 sales. And now here what happened? Suppose 300 is there. Suppose 400 is there. 500 is there. The sales might be is equal to 3000. Now here Suppose 120 is there. Suppose is equal 220 is there. 220. And this code 320 is there. The sales is equal to 1200. I will write one more thing. And 150 is there. And 300 is there. And 450 is there. 450 is there. The sales equal to 2500. This is your data. This is your data. Think like that, like this 100 observations are there. How many observations? 100 observations. Step 1. Step 1. We divide our data into, nowadays they are doing 2 parts, but in previously they have done 3 parts. Divide into 2 parts. One part is called train data. Another part is called test data. What is that? Train and test. You need to understand this concept because this ML concept. You need to understand this train data and test data, which means I will divide 100 observations in such a ratio 70:30 or 80:20 or 60:40. That is based on our wish, based on the data. So what is meant by 70:30? What mean by 70:30 means? Which means out of 100 observations, 70 observations are train data. And similarly, out of 100 observations, 30 observations are test data. 30 observations are test data. Understood? This is step 1. Clear? Any doubts? Saurav? Good. So what we are doing? We have 100 observations. We want to divide into 2 parts. Train data and test data. So train data 70:30 means what is the meaning is called? 70 observations under the train data and 30 observations is in the test data. Which one more? 70:30, 80:20, 60:40 is generally our internal discussion, that is internal. Okay. Suppose think like that. Always imagine only one node point. Train data should be high. Train data should be high. Because I want to train my kid. If I want to provide the more data, he can understand more, right? If I give only 2 lines, he can't understand, right? He can't think beyond the 2 lines. So provide the more data is very, very important. So train data should be very, very high. Now, there's some more scenario is there. How much you require train, how much you require test. So 10K observations is there. 10K observations is there. Suppose you require 8K observations for train and 2K observations for test. 10 lakhs is there. How much is there? 10 lakhs is there. For 10 lakhs, you no need to divide to 8 lakhs plus 2 lakhs because 2 lakhs also huge observations. So you can provide into 99 lakhs. So 9.9 lakhs as a train data and remaining 10,000, 10K for test data also is enough. Because testing purpose is very, very low is also enough. Testing purpose. For the train, because 10K observations also not an easy observations, right? 10K also is very huge. Very, very huge. And this you divided 80:20. This what percent? And a huge data, 10K observations is not less observations. 10K observations is not a less observation. Now suppose 1 crore observations are there. 1 crore. 99 lakhs are the train data. 1 lakh is the test data. 1 lakh observations are not less observations. So that is the based on the discussion, we need to divide like this. Either you want to provide 70:30 or like that. Suppose you have only 1000 observations are there. 1000 observations. Then obviously you will go to 70:30. 70:30. 700 plus 300. 700 plus 300 or 800 plus 200. But you will not go to 900 plus 100, right? Because 100 to test is very, very less. So this is a generally a discussion. So 70:30, 80:20, 60:40. Understood everyone? So what is the first step? We divide the data into two parts. One is the train part, test part. So in the train data also, we have total data will be there. What is the data? Newspaper, TV, social media, and sales will be available. Sales will be available. In the test data also, we have newspaper will be available, TV will be available, social media will be available, sales will be available. Same will be available, but the observations are different. Here the observations is what happened. Here the observation count ID. Here might be first ID. Here might be second. Here might be third, and so on. How many observations will be there? How many observations now? That is 70 observations, and so on. 70 observations like this. And here what will be there? 71 से शुरू होता. Here what will be there? 71. So 71, 71, and 72, and 73, and so on. What will be there? 100 will be there. Because you divided. But what is the problem in this division part? What is the problem in this division part? You divide into serial number only. Exactly 70 is one observation, 30 is one observation. What is the problem in this? So there are 100 people are there. In that 100 people, 170 people are Shah Rukh Khan fan. 30 people are Salman Khan fan. You take in only Shah Rukh Khan fan at side, Salman Khan at side. Then how can machine learning will learn? Where is the pattern? So these kind of things what happen, you might be have biased. Because you are taking 70 people Shah Rukh Khan fan and you want to train the data. What is the output it will say? New data will pass. Shah Rukh Khan only say, na? Even though you send the Salman Khan fan also, what is the output it will say? He is a Shah Rukh Khan, he is a Shah Rukh Khan, he is a Shah Rukh Khan only. That means you trained with the same output. That might be possible, right? You train with the same output. So what we need to do? We need to take output labels also equal proportion. I need to pick Shah Rukh Khan fan as well as I need to pick Salman Khan fan. If I pick only Shah Rukh Khan fan, then my model will understand whatever kuch bhi do, he is a Shah Rukh Khan fan. It's called bias. It's called what? Biased. I am biased to some people. Okay. If anyone is biased to some people, what happened? Like he is a foolish, right? Whatever you said, he will not listen. Okay, Shah Rukh Khan is great. That's it. Virat Kohli is great. That's it. They'll say that only. Whatever you say, they'll not listen that. So that's why. Never argue the foolish people. Just say that, okay, if elephant is fly, yes, you are correct. Yes, elephant is fly. Then leave it. That's a never ever argue with three kinds of people. Those who are biased with film stars, political parties, and religion guys. Can never ever talk anything. If they just say, okay, elephant will fly. Yes, bro. Just leave that position. So that's why what you need to do, instead of taking one, we need the data into randomly. We divide data into randomly. Understood? That is, so now suppose see here. I'll just show you to make you understand more. We'll take one EDA data. EDA session 1, session 2. Okay, let's take this session. Understand these concepts is very, very important. I'm just running this data. I'm just running this data. So Visa DF, we are taking this. Now, you know, in this, how many observations are there? 25,000 observations are there. Now, what happened? Everyone is what happened? Denied is there, certified is there, denied is there, denied is there. Here is automatically what is there? Different observation, different outputs are there. Think like that. There are exactly same observations starting denied is there. And after that, certified is there. Then you divided that into two parts. Then what happened? There is no pattern learning. Because everyone is what happened? Certified. Everyone is what happened? Denied. So that's why we need to do that. Suppose from, I'm just showing this from sklearn dot model selection. Train split. Automatically, what is there here? Train test split will be. Train test split. Then you need to pass your X data and Y data and how much percentage you want to split and what is the random also you need to mention. So based on automatically the code will take care of it will divide the random will divide. So you need to pass your train data, you need to pass your X and to provide that random and shuffle everything automatically will provide that. So that it will divide. You don't need to divide manually. Automatically Python code will take care of. But only thing is what happened? We divided data into two parts. One is train data and test data. And that too we divided what? Randomly. We divide into randomly. So that we are good, right? So that is good. Correct, Saurav? Very good. So which movie you watched last night? Hmm? Hmm. We divide into randomly. Aquaman. Aquaman 1 or 2? 3. So we divide into randomly. Now, step 2. Machine learning, any machine learning model will develop by using train data. By using train data. So train data has both input variable and output variable. So machine learning model will develop by using which data? Train data. That's why train data should be very, very high. This is the second step. What is the step 3 now? Once you train the model, then model is ready. Model is ready. This is very, very important. Then we'll pass test input data. Test input data. What is the input data here? That means we'll pass newspaper, comma, social media, comma, TV observations. We'll pass these three values to the model. To the model. Newspaper, social media, TV to the model. What is that noise? Thank you. Newspaper identified? No. Newspaper, social media, TV to the model. Then what model will give? Model will give one answer, correct? Model will give one answer and that is called predicted values. What we call predicted values. But more test data has output data also. Test data has output data also. You divided, right? You divide into which part? Two parts. Train data and test data. Both have input columns, both have output columns. But model will develop which data? Train data. Then their model is ready. You will pass the test input data. What will pass? Test input data. Test input data TV to the model. Then model will give one output. That output is called what is called predicted value. And this data is called actual values. What is called? Actual values. Actual values. Understood? So test data will give that. You can actual sales, and this is called what? Predicted sales. Predicted sales. Now step 4. What we'll do? Compare this actual sales and predicted sales. Like this, suppose, like this. Newspaper. So data is the T newspaper 400 rupees. When you are passing 400 is giving the 4,000. What is giving my model? 4,000. And that is called the predicted values. That is called the predicted values. So the predicted value now how much? 4,000. Predicted value is how much? 4,000. Because train data used for train data, you develop the model, and test data used to test the model. Test data used to test the model. For testing, you should pass only input. You should not pass the output. So whatever you are saying the answer, I need to compare with my original. Give only question paper. Then what you will write? Answer. Then I will verify with my answer. That is called test. That is called test. You provided the answer before I trained you. So that is called the trained data. So again, we are telling you what is the first step? Divided data into two parts. One is the trained data, another one is the test data. Both has input columns, both has output column. So trained data used for to train the data. So train the machine learning model. And one model is ready, you will what will pass? Test input data. Don't say test data, test input data. When you send test input data, the model will give what? Some value. That value is called what? Predicted values. And that predicted values will compare with test output data. That now the model output is nothing but predicted values. Predicted values will compare with test output data. It is called actual values. Actual values. Actual values. If both are equal, we are good. Both are not equal, then something is happened. Something is fishy. And to identify that, we have some metrics. So this is the story we will develop in machine learning. So the terminology is called train terminology and test terminology, input variables terminology, output variable terminology, actual values terminology, and predicted values terminology. Tell me, what is the terminologies? What is the train data? Tell me, what is the train data? Bolo no. To be divided into two parts. One is train data, another one is, so you need to divide data to, should be randomly. Data should be divided into not line by line. 1, 2, 3, not line by line. So now, what is the input and what is the output? Generally, input is nothing but input columns. Output is generally output columns. Train data used to develop the model. That is called train the model. That's what the train term used. Now test data is used to test the model. While testing, what you will pass? Input values. So model will give one value, and that is called predicted value. Test data already has output values. That is called what? Actual values. So what you will compare? Actual and predicted. Any doubts in that? Can you please confirm the chat? Nikita is good. Arun is good. Srishti is good. Priyanka is good. Naran is good. Very good. Yeah. So this is the story. Now here I am saying the model, right? Here I am saying the model will predict the values. What is this model equation? What is this model equation here? What is the model equation? Tell me. What is the linear regression equation here? Y is equal to beta naught, beta 1 into newspaper, beta 2 into social media, beta 3 into TV. And this is the equation of the model. This is the equation of the model. This is the equation of the model. And in this equation, we are passing newspaper equal to 500 value here. Social media equal to 400 here. And TV equal to 200 here. TV equal to 200 here. So if you know that beta 1, beta 2, beta 3, beta naught, then you will get one value. Yes or no? You will get one value. That is called model development. So identifying the coefficients, identify the bias is called model development. Because this is the equation. Beta 1 into newspaper, beta 2 into social media, beta 3 into 200. How you got 4000? Maybe here some value 10 is there. Here some value -4 is there. Here some value 2 is there. Here some value 100 is there. What is the answer? Tell me. What is the answer now? Y equal to 100 plus 5000 minus 1600 plus 400, and the value equal to 4000, 1400, 5000, 5000 and 5500. 5500 minus 1600. How much that is? 3900. 3900. So our value is nothing but 3900 you got. 3900 you got. So like that. So the equation will fix. So what will change? Coefficients will change, your value will be changed. So coefficients are changing, your value is changing, final outcome is changing, and comparison also will change. Before you compare now 4000, now you are comparing with 3900. This is your actual value, right? Your values are very, very bad. Very, very bad. You will get 200. Where is 3000? Where is 200? Your values are very, very good. You will get 2900. Then that is good. So 3000 and 2900, very, very good. Your values are very, very bad. You will get 60,000. Where is 3000? Where is 60,000? So you are getting high, we are getting low. That is not matter. We are getting around the original value or not? We are getting around the original value or not? If around the original value is not there, the deviation is more, means your model is very, very bad model. So that's why who is responsible here? Who is responsible to get this value? Coefficients and bias. Yeah, Aja, I'm waiting for you only. The coefficients and bias. Beta 0 is nothing but bias, like intercept. I will tell you the exact meanings are there. Exact meanings are there. So finally, the goal in machine learning, the goal in linear regression, tell me, what is your goal? What is your goal in linear regression? Identify the best line. Identify the best line. How can you identify the best line? By identify the best coefficients. So that's why identify the best line is our main goal, by identifying the best coefficients. So finding the suitable coefficients in order to reduce the error. So that is your main goal. That is your main goal. This is the main goal in linear regression. Identifying the best line by identifying the best coefficient. Are you getting the idea? Your coefficients are changing, your value will be changed. Coefficients are responsible for line rotation. So the line is going, you want to go to south, but line is going north. That is very, very worst model, right? Like that. So both are interlinked. Everything is interlinked. Now search linear regression in the Google. You can see some lines. You'll see some lines here. You'll see the lines. What is the dotted? Data points. We can't imagine that more than 3-dimensional, right? That's why we will use only 2-dimensional. Because in your original data set, how many dimensions will be there? Always. Minimum more than 3. That is the data set, right? In Visa data set, how many columns are there? 13 or 12 or 17? Forget. 16 columns are there. Then how much dimensions of data? 16 dimensions. You can't imagine 16 dimensions, right? But if you imagine, it will be like this. All the data points. All the data points. Your red line should pass through the in between the data point, which means your predictions are good. Which means your model is predicting that good. It might be exact equal. It might be around that value. But it is not like that Bakwas model like this. See this model. This model is not at all predicting each and every one, right? Nothing is not predicting that. So this is a waste model. This is a good model. Understood, ma? Everyone? Yeah, again tell me. So what is the important in the linear regression now? Identifying the best line. How can you achieve that? Identifying the coefficients. Now this is a very, very famous statement now. Finding the suitable coefficients in order to reduce the error. Now let's come to the first thing is what is mean by error? What is mean by error? What is mean by error? Error is nothing but very simple. Actual value minus predicted value. What is that? Actual value minus predicted value. actual value minus predicted value. Actual value minus predicted value. That is the error. Very, very simple. Actual value minus predicted value. So generally people have different terms. Ma? Y is nothing but a generally output, right? Y is generally an output. Y is generally and referred as output, and Y actual. People write Y actual like this. Y actual and Y minus Y predicted. Y predicted like this. Y actual minus Y predicted is called error. Y actual minus Y predicted is called error. If this error equal to 0, then we are good. If error is huge, then we are not good. Simple, straightforward. Error equal to Y actual minus Y predicted. So Y actual means original data, original output data. Y predicted means when you pass that corresponding input, what model is giving? What model is giving? That is a test. Y predicted is nothing but model development work. That is the error. Now, second thing is called. Now we already seen this kind of always a problem. Why always a problem? Think like that. Think there is the equation is there here. X is there, Y is there. And let's make this one. X is there, Y is there, and Y is there. Okay. The three values are there. So here X is there, here Y actual is there, and here Y predicted is there. Y predicted. Or I will take the original example, so that will be very easy. I will take the same example. This one only I will take. This one only I will take. Terminology is very, very important. Ma. Social media, newspaper, this is original data, and the model is equal to this called. This is called Y predictions, right? This is called Y prediction. This is called Y prediction. So Y predictions equal to. So Y predictions equal to. Y prediction equal to, what is the formula? Beta naught, beta 1 into newspaper, beta 2 into social media, and beta 3 into TV. And this is what? Sales is nothing but what? Y actual. Sales is nothing but what? Y actual. Is equal to Y actual. That is called sales. Any doubts? Sales equal to Y actual, and this is Y predicted equation. This is Y predicted equation. For the first observation, you got 3200. And some second value is there. Suppose 400 is there, and 550 is there, then 250 is there. You have 2800 is there, but the value got 2600. You already find, think like that. You already got beta naught, beta 1, beta 2 values. You submitted here, you got these values. Assume like that here. So when you are passing 500, 400, 200 to your model, how much answer is getting? 3200. When you are passing 400, 550, 250, how much it is getting? 2600. Then calculate the error here. Calculate the error. Error equal to Y actual minus Y predicted. Y actual minus Y predicted. So what is the answer? 3000 minus 3200. That is equal to how much? Minus 200. And this is how much? 2800 minus 2600. How much is called? 200. 200. So first observation, error equal to the sum of errors. Then sum of errors. Calculate the sum of errors. Sum of error is equal to error 1 plus error 2 plus and so on error n. That we learn in the statistics, same like that only. The statistics, error 1, error 2, error n. So this is error 1, and then error 2, and then error n. You can write like anything, that is. Some people write error also. Error 1, error 2, and so on. Terminology is very, very important, ma. Terminology is very, very important. Error n. Can you replace what is error meaning? Y actual minus Y plated. Now, how can I replace this? Total error equal to, I'm writing total error. Total error. Total error. You already know the summation, right? Now tell me, how can you write the summation? Summation. Write it. Summation. Same. If you are not able to understand, please ask me, ma. Summation I equal to n, and then error you will write. Then error. Error I. Error I equal to 1 to n, and I will remove this. So this is the summation, correct? I don't know why it is coming. Okay, let's do this. Error I. Error I. So I equal to 1, I equal to 2, I equal to n. This is everyone understood? Can you please confirm the chat? Today is some hectic class, ma. All mathematics only today. Okay. So be ready with that. Don't sleep. Now, next. We are good, right? Now, can you replace this error with this here? Can you replace this? This is another way. Now I'm replacing in another way. Y actual minus Y predicted. Y actual minus Y predicted. First value. Second value. And so on, last value. And so on, last value. So Y actual. So 1. Y predicted 1. 1 means what? First observation. Y actual 2. For second value, I am predicted also second value. Line by line. And Y actual n. And predicted also n. Predicted also n. Now, if I want to write like this, same like this. So Y actual minus Y predicted. And this is I. This is a total error equation. Total error equation. Total error equation. Everyone is good? ఎక్కడ సేమ్ ఉంటాయి డిఫరెన్స్ ఉంటుంది అందుకే కంపేర్ చేసి ఎర్రర్ ఎంత వచ్చిందో క్యాలిక్యులేట్ చేయాలి మోడల్ నుంచి వస్తే మోడల్కి పాస్ చేసేది ఏంటి మోడల్ పాస్ చేసేది ఆ ఇన్పుట్ డేటానే కదా మోడల్కి పాస్ చేసేది మనం ఈ ఇన్పుట్ డేటా 500 400 200 పాస్ చేస్తాం టెస్ట్ డేటా పాస్ చేస్తాం సో టెస్ట్ డేటా ఇచ్చినప్పుడు 3200 వచ్చింది దానికి కరస్పాండింగ్ ఒరిజినల్ వాల్యూ ఏది ఉందో కంపేర్ చేయాలి కదా దాని కరస్పాండింగ్ ఒరిజినల్ వాల్యూని తీసుకోవాలి. వేరే ఏదో తీసుకుంటలేం మనం. ఆ డేటానే పాస్ చేసినప్పుడు ఆ కరస్పాండింగ్ ఒరిజినల్ వాల్యూతోనే కంపేర్ చేస్తున్నాం. అలా. Everyone is good, right? If you're not able to understand, ask me now only. Okay. Linear regression, outside people will finish only 2 days. Okay, only 2 days they will finish. They will not cover this mathematics. You can ask in entire Naresh Shetty, previous batches, all batches. No one will cover maths. No one will cover maths. But I will teach maths. I will make you perfect in maths. You just follow like me. So what is the error? Error equal to actual minus predicted. How many observations are there? That many errors we need to calculate, correct? In test data, how many observations you taken? 2. So how many errors you will get? 2 errors. How many errors you will get? 2 errors. Now, for 2 errors, can you calculate the total error? How much the total error? How much the total error now? The total error equal to, you have only 2 observations. You have only 2 observations. That is coming 0. That is still 2. That is 2. Then total error equal to, and this value y actually is how much? 3000, huh? And this is 3200. This is just assumption, ma. Okay, this is just assumption. Assume that you already have a values. It is just assumption. Don't ask me how we got the values. And this is what? 2800. And this is 2600. And again total error. What is the total error value now? That equal to 0. The same statistics. Then the total value becomes 0. What is the next possibility thing? Deviation becomes 0. That's why what we learn? What we learn? Deviation equal to 0. What we learn? I remember in statistics. In the variance concept, first we will learn about range. Then we'll learn about deviation. Mean deviation, correct? Mean deviation. Mean deviation we got calculated. All the deviation become 0. Then we'll go with absolute mean deviation. And fourth one is what? Absolute. What is the fourth one? Variance. And what is the fifth one? Standard deviation. This is the progressing, right? We are doing standard deviation. This is the progressing we are doing. That's the same concept, right? So your all total deviation becomes 0. Then you are trying to avoid the total error should be not equal to 0. Because I am seeing the error, but my total is saying what? No error. Mathematics will fail. So that's why what we have gone for absolute. But absolute, you know already drawback. So that's why what we have gone now? Squaring. So now next part is what? Squared error. Now error become what? Squared error. Write it. Error become now same concept, same thing. Everyone note down that. You should show me now. First one is error is done, and second one is what? Squared error. Squared error. Second one is squared error. What happening? You want fan or you want light? What happening? Huh? You want AC? Then why that switching off and on all these things? Squared error. Or you are playing in the class? Or you are making some symbols, some code? Hmm? Tick, tick, tick. It means some code. Hi, how are you? Tick, 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 tick. 4 things. Hello, I am good, fine. Are you making some kind of codes or what? Squared error. Now all the formula, how the formula become now? Tell me. First error. What is the error formula? This is error. I'm just writing this. Just apply the square, ma. Just apply the square. This is very, very easy. Just apply the square. Apply the square. First formula, second formula, third one. Four. So I'm doing what? Square. Error square. Error square means power. Very good. That means y actual minus y predicted whole square. Correct, Saurav? Good, right? Then what happened? Total error become what happened? So instead of total error, what will write? This is a squared error. This is a squared error. Error square. That is sum of squares errors. Sum of squares error. What you are doing? Sum errors. Which errors? Square errors. That's why sum of square errors. SSE. What the shortcut is called? SSE. Sum of square errors. Sum of square error. Sum of square error. That means error 1 square. Error 1 square. Error 2 square. And error n square. Oh my God. I forget. 1 minute. $10.35. Make that formulas. Complete that formulas. So total error equal to total error is what? SSE. SSE. SSE equal to error square. Error square. Which class? No more. Give me 1 minute. I'll just finish this. Okay. So sum of square errors SSE done. SSE. Square. Square. Murli, able to write? Very good. Very good. Not DevOps. No DevOps. So SSE, sum of square errors. Sum of square errors. Everyone is good, right? Can you please confirm the chat? Next, third one. First one is error. Second one is SSE. Third one is called mean square error. What the third one is called? Mean square error. Squared error. SSE. We can say SSE. Sum of squared errors. S sum of square errors. So mean square error means what do you need to add? Mean you need to add. What do you need to add? Mean. Mean sum of square errors. Mean. Generally they will call MSE. MSE. Mean square error. So simply the same formula will become what happen now? By n. By n number of observations. And this is called MSE by n. Correct? N means nothing but number of observations. Mean square error. We started with error. We went to SSE and then we come to MSE. Now I'll write the abbreviation, you write the formula, okay? I'll write the abbreviation, you write the formula. Okay, Jayant? Very good. And the abbreviation is fourth one. So generally it's called mean square error. Don't write mean sum of square. Mean square error. And it's called RMSE. Tell me what is that full form? Root mean square error. Write it. What is the formula now? See, mathematics easy. No difficult in mathematics. Mathematics dead easy, that is. Root mean square error. Then what you write? Just apply the root. Apply the root. My wife feel very happy and she always saying that, Amma, you can teach to kids to maths. That is. So everyone feel like that math is difficult, right? But math is not difficult, ma. Root mean square error. RMSE. Root mean square error. So total 4 formulas: error, SSE, MSE, RMSE. We started with error, we squared it, we by n it, and we root over it. Simple. Same story. And it is look like what? Variance, standard deviation, right? It look like variance and standard deviation. Now 4 formulas. Again, I'm writing here 4 formulas at one place. At one place. First one is the total error. Total error. And before that error. Before that error. No need to by heart, ma. No need by heart. How we progress that, you need to learn that. Error, total error, and then sum of square errors. And then MSE, mean square error. and then RMSE, root mean square error. Any doubts in this? Error, total error, sum of square error, mean square error, RMSE. Now, we are good, right? Can you please confirm the chat? Some textbooks, error also called as residual. What they call? Residual. Error also called residual. Error also called residual. Residual. Then SSC, sum of square errors. Sum of, I will ask these questions, ma. You need to create the PPT and you need to explain this, all these things. Sum of square errors also called residual sum of squares. That means SSC become RSS. Not that RSS, what you are thinking. Okay. SSC becomes RSS. Residual sum of squares. Both are same. SSC become RSS. So, no? SSC become RSS. Error, total error, sum of square errors, mean square error, RMSE. Root mean square error. Error also called residual. Then sum of square errors becomes residual sum of squares, RSS. SSA and RSS. Error is nothing but actual minus predicted values. Predicted values will give the model by passing the test input. Actual value is nothing but actual test output. We are comparing both test output with model predictions. If both are is good, then model is fine. If both are is wrong, we need to work on the model why it is wrong. So that's why now next is there are two more important thing is called cost function versus loss function. Those who studies textbooks only, they know all this terminology. Okay. Cost function versus loss function. Cost function versus loss. Next, one more thing is called loss function. So loss function means error only on one observation. Error only on one observation. Error only on one observation. If you're talking about only one sample is nothing but that's called loss function. Okay, that is error only, but only one sample. Sample wise sample. Observation wise observation. If you talk, what is the terminology is called? Loss function. Loss. How much loss you are getting? How much loss you are getting? Then overall total cost means overall error. How much cost is happening? How much cost? How much loss is means what happened? Single observation. Cost means what? Total entire error. So next cost. Cost function refers to entire error or total data error or total error. Total error. Total error. And cost function denoted with J, denoted with J. So don't ask me why it is J. I also don't know. Okay. Research, but I asked maybe scientist name I thought, but it's not scientist name. They given just like that. It's a J. Cost function denoted with a J. Now J is nothing but, can assume that this is a cost function, generally sum of all errors. So this is a J. This is nothing but J. Cost function. Is J. We can add 1 by n or without 1 by n. That is never matter. That is no need to worry. 1 by n just mean that you are just reducing the error in other term J. And this is a cost function. The J. Cost function is J. So where we are reached now till now? J is the cost function. There are so many names for this, right? SSC, RSS, and the cost function. The three names for this. So you can cost function is same as SSC. Cost function is same as SSC. So I'm just removing this. So cost function also called as SSC, and also called as RSS. Cost function equal to SSC equal to RSS. You can give equal to, that is better. Equal to SSC equal to RSS. Both are same. All are same. Cost function equal to SSC equal to RSS. But in the textbook, they will always talk about cost function. In deep learning and AI also, they will talk with the cost function. So cost function is very, very simple. Error square. Sum of all the errors. So what is your main goal? To reduce this cost function is our main goal. To reduce this cost function is our main goal. Because you need to reduce the total error, right? You need to reduce the total error. So our main goal is, so again, goal in linear regression. The goal in linear regression is we need to reduce the cost function, which means we need to reduce total error. That is the goal. How can we reduce? By finding the suitable coefficients. Are you with me, guys? Can you please confirm the chat? Everyone is good? Arun is good. Nikita is good. Yeah, please confirm the chat. Yeah. So we need to reduce the cost function. Which means we need to reduce the total error. So this is the cost function. Let's take that your y predicted equation. Your y predicted equation is a simple linear regression equation. This is called beta naught plus beta 1 into x1. A simple linear regression equation. Assume that. This is your y predicted equation. Assume that y predicted equal to beta naught plus beta 1 into x1. A simple equation. Now, if I replace this equation here, if I replace this equation here, I replace this equation here, I replace in this equation here like this, and this equation again becomes, note down step by step, this very, very simple things. Now it is minus b naught. It is minus b naught. It is minus b1. Correct? So this is the equation. Y actual minus beta naught, beta 1 into x1. Jacobian matrix. Yeah, that is a matrix, but the cost function this is. Jacobian distance. A union B by A intersection B. Jacobian matrix and Jacob distance. But this cost function is different. That J is different. Beta naught minus beta 1 into x1 into I. Good, right, everyone? Pakka? Till now? Okay, once I'll recap. Okay, because the asli picture abhi bhi back hi hai. Okay, there is asli math hai after this. Okay, that's why we'll do one more time recap. Just to recap this. So we started with so much maths today. We started with error. First, we started with what? How the machine learning model will works. So step one, what happened? We divide our data into two parts, train and test. So I'll divide into 100 observations into 70 and 30. And then we trained our model with what? Train data. Then model will develop. So you need to test the model. So you need to pass which data now? Test input data. Test input data. The model will give what? Some predicted values. But already test data has what? Actual data. That means you are passing 500, 400, 200 to the model, and model give what? Suppose 3500. But actually that corresponding input as also original output is there. That is called 3000. You need to compare these two. That's why this is called actual data and this is called what? Predicted data. Clear? Our entire whole goal in data science in AI, what? We need to reduce the error. We reduce the error. So now what is the goal here? Finding the suitable coefficients in order to reduce the error, because we already know that because of the coefficients only our value is changing. Our value is changing means our line also will be shifting. A line also is rotating. So we need to get that good line. And then we got the error. Error is nothing but what? Actual value minus predicted value. But there is a problem in this. When you add the total error, error 1 plus error 2 plus error n, then we are getting total error equal to what? 0. So that's why we are what in doing? Squaring. Because we already learned in the statistics, absolute will fail. Absolute will fail. What the next thing is there? Variance is there. Variance is nothing but square. So we are squaring. What the terminology is called? Sum of square errors. That is called SSE. What the terminology? Simply we are just applying the squaring. And then if you want to apply the mean, that is called mean square error, that is 1 by n. And then if you want to apply the root, that is called root mean square error. This is all we need to find. All we need to find. And then these are the 4 formulas: error, total error, SSC, MSC, RMSC. But there are important 2 things are there. Error also called residual. So SSC become what? RSS, residual sum of squares. So cost versus loss. Loss reference with single observation. Cost refers to all the observations and denoted with J. And this is y actual minus y predicted. And that predicted value, suppose the equation is called beta naught plus beta 1 into x. We substitute here, and this is our final cost function equation. Final cost function equation. Good, right? Now it is look like a y is equal to x square. So it will look like what? Y is equal to x square. Is nothing but a what? Parabola. Nothing but what? Parabola. So I will close after explaining this. Okay. Tomorrow we will do more maths. Okay. Tomorrow is a more maths in entire machine learning. Okay. So be ready with that. It's look like this. So it is a J. It is beta naught. It is beta 1. And this is the cost function look like this. Cost function look like this. I'm not getting properly. The parabola. You need to find this point, minimum point, suitable point with all respect to J and beta naught and beta 1. I'll show here. Linear regression cost function. Look like this. 3D diagram, right? 3D diagram. The line changes. It will slowly see. Now its line is rotating. It reaches to minimum point. Minimum point means what? This is the minimum point. This is the minimum point. Correct? Minimum point, that is the minimum point. How we are achieving? See, the line is rotating. Whenever it is a line is good fit is coming, automatically. If line is very, very bad, that means your error is very, very high here. Slowly, error is decreasing. And finally, what it is reaching? Minimum point. When it is achieving minimum point, you got very, very best line. So this look like is a parabola. See, parabola, but in 3D diagram. Why 3D diagram? Because in real time, we have more coefficients. We have more input columns. More input columns means more coefficients. More coefficients. More coefficients means again more dimensions. Input columns is nothing but what? Dimensions. So that's why we are getting the 3D dimensions is showing that. So like this. What you are seeing is called is generally, see, it's coming like this. The logistic regression curve. Those are the curves. All are the cost functions. Now what is the cost function formula? Summation. So h theta is nothing but your data. This is y actual minus y predicted. Some people will write like this. That is J. Different people will write like the different ways. Some people are theta naught theta 1. Theta naught theta 1 means here they are writing like this. So that's why only follow my notes. Okay. So they will write like this. They will write J beta naught comma beta 1. It is a combination of this J equation is a combination of beta naught beta 1. It is coming like this, guys. Suppose a equation is there. F is equal to 2x plus 3y you can write like this is f of x comma y. F of x comma y. What is the meaning of this? This function has combination of x and y. And the same way here also, they will write like this. This function j is a combination of beta naught and beta 1. So like that they will write. So don't confuse with the notations. Different textbook will follow different notations. So you need to understand how the cost function is there, how the cost function is located. So I'm just copying this diagram here. And tomorrow we will find these coefficient values, coefficient formulas. Because our main goal is what? Finding the suitable coefficients. So how can we find the coefficients is the next step. Now you know linear regression equation, you know cost function. You know what is the goal in the linear regression. And tomorrow what we will see? How to find the coefficients. How to find the coefficient. Linear regression is a very, very important in the interview process. Like tell about yourself is a very, very common question, right? Same like that common questions on the linear regression. Linear regression, everyone will ask questions on the linear regression. Everyone. Like in interview, tell about yourself is same as questions on the linear regression is same. Understood now? We are good, right? Are you getting something now, ML? ML is interest or deep learning is, sorry, statistics is interest. ML is interest other than statistics. Yeah, because we are more than 100 people now, only 50 members are coming every day. 50 members are gone. 50 members are coming every day, maximum 60 members. By end of machine learning, again 20 members will gone. And deep learning, I am thinking only 1 or 2 members will be available in the class. But don't be like that. Attend the class every day. Okay. If you're not understand, ask me. I will give my best to make you to understand. Okay. Thank you. Thank you so much. Tomorrow is a very, very good maths. Be ready with that. Don't sleep. Don't watch movies in night time. Saurav. Okay. Thank you, ma. Thank you so much.
బాగుందా బ్రో